Ladies and gentlemen, please welcome Raj Yavatka.
So I'm here to talk about EVO SDDC, which we believe is the easiest way to do private clouds in large enterprises or medium enterprises. I'm going to start with a reference to yesterday's keynote, where we believe strongly that the world is moving to hybrid apps. These apps can run anywhere in private cloud or public cloud. So naturally, the next question comes: so the hybrid apps require both public clouds and private clouds. Public clouds are known for their agility and availability, and those kind of things are missing when it comes to private clouds, because enterprises have to get those up and running, and that's where the challenges come I'm going to talk about in this particular presentation. Now, when you create a hybrid cloud, you have public cloud, private cloud connected together using some advanced networking services, so you can do vMotion kind of things, so that the app can migrate seamlessly between the two environments. Underneath all that is a cloud management platform that ties the hybrid cloud together. And foundation of all of this, we believe, is the software-defined data center. That makes it easy to build such hybrid platforms. Now, if you ask any enterprise IT about software-defined data center, they have been hearing about it for the last 3-4 years. They do believe in it in terms of a path towards creating private cloud, but it is not easy to create software-defined data centers. One approach is so-called hardware-defined approach, in which you start with the proprietary hardware, you build lots of intelligence in that, add some software, but you have to do everything manually, so the operational cost of bringing up software-defined data center and bringing up our private cloud and running it is very high. On the other hand, you have software-defined approach, which believes that you can start with x86 industry standard architecture. Don't tell me the clicker is not working. Okay, you start with the industry standard hardware, you add more intelligence in the software layer across compute, storage, and networking. And you also take away the intelligence from the proprietary hardware, instead build lots of automation so that the IT can focus on solving the line of business problem and making it easy to move the line of business at the speed of expected out of the public clouds. So in general, when you ask people what does it take to do software-defined data center, they cite several challenges, even though they buy into the idea. One of the first problems is the upfront investment that you have to make. Many times the customers do not know where to start. They need some kind of a reference architecture that somebody has to provide. They have to identify the both hardware and software components that have to be procured, built together. And they have to invest a lot of time, somewhere between 3 to 6 months sometimes, before the first VM can be deployed. And yesterday, if you attended a talk from one of our internal VMware IT team that has done private cloud based on EVO SDC, they showed you how they cut down on the amount of time required to build a private cloud from as much as 1 quarter to a few days. Second problem is, once you have procured all the components, brought them together, how do you bring them up? That itself is a challenge, because you have disparate pieces of infrastructure, compute, storage, networking coming from different vendors. They have different management tools. They have different ways of managing that infrastructure, and there's no automation. So that itself makes it a challenge to bring up the entire environment without resorting to some finger pointing among the vendors. And lastly, but not the least, is the biggest challenge, which is lifecycle management. The software-defined data center requires you to bring together many pieces of the infrastructure together in one place. And how do you manage the lifecycle of that, both hardware and software, in terms of patching it, upgrading it? And many customers tell us that they take an enormous amount of effort throughout the year to do lifecycle management. So these are the challenges that is keeping people from having widespread deployment of software-defined data center as a means of creating private clouds. What VMware has been doing is that we have been a leader in hyper-converged infrastructure, where we are bringing together compute and storage virtualization on a x86-based standard hypervisor. And that level of integration makes it much easier to start creating software-defined data center, because first you get full product level integration, you have vCenter-based uniform management that people are used to. Of course, we have seen through third-party independent analysis that you can save as much as 50% in TCO as a result of this level of integration done between compute and storage. And of course, you get performance because vSAN, if you are familiar with vSAN 6 now that just came out, the performance is outstanding. You get up to 7 million IOPS in an installation. And of course, you have flexibility of different types of vSAN ready nodes that we qualify. So that's the first step. So just to recap, if you're trying to create a private cloud based on software-defined data center, you have one option, which is build your own, which you end up doing all the work. As a result, you are not agile and the complexity is high. Hyper-converged infrastructure takes you further in the direction of reducing this by taking you to the so-called top right-hand corner of the magic quadrant, where you can be more agile and less complex. And we believe that EVO SDDC product that we are launching at this VMworld with our partners takes you even further by making it as agile as public clouds and also reduces the operational complexity. Now, what does EVO SDDC do? So if you look at on the left-hand side, you're familiar with all of our stack in terms of compute, storage, networking, virtualization. On top of that, the management suite with respect to vRealize operations, vRealize log insight, and even vRealize automation. What we are introducing as part of this product is a centrally managed distributed management piece of software called EVO SDDC Manager that integrates all of these pieces together in a way that you can deploy them together in an interoperable manner with a pre-qualification and pre-testing on specified hardware. So what you get out of this is simplicity, agility, and availability at data center scale. And that's what we are trying to match with respect to the experience people want to see. So with respect to how it comes about, if you look at data center scale private cloud, what EVO SDDC does, it brings together one or more racks. You can start at 1/3 rack or so, add one server incrementally as you add capacity, but you can scale up to multiple racks. And you get pre-integrated compute, network, storage, virtualization, and our management software, all integrated together through the EVO SDDC Manager. And all of this can come together, and you can bring it up in a software-defined data center in 2 hours or so. At this point, one of the things you get out of this infrastructure is the scale out, because as I said, you can start at 1/3 rack, add incremental capacity up to multiple racks. And for each rack, we believe that based on canonical configurations of virtual machines, you can get up to 1,000 infrastructure as a service VMs, up to 2,000 virtual desktops, and about 2 million plus IOPS out of vSAN configuration. So that's what you get out of the entire experience when you start bringing together a private cloud. And at this point, I would like to invite my colleague Anil Kapoor to show you a demo of what does it mean to bring up such a software-defined data center in less than 2 hours. Anil?
Hi, everyone. I'm Anil Kapoor. I'm a product manager, and I work for Raj. And I'm really excited to be here today to talk to you about EVO SDDC, the easiest way to deploy your SDDC. Now, I want everyone in the crowd to just close your eyes and imagine. Imagine you've purchased an EVO SDDC bomb, and that it's arrived at your data center, and you've put it in place, and you've hooked up the power and the networking. What do you care about at that point? You care about 2 things. First, you want to set a common set of services that can be used across the private cloud deployments that you build over time. And number 2 is you want to take that rack and you want to have it communicate with other racks in your data center, as well as have it integrate into your existing data center. And we're going to show that right now with this demo. So here we have the setup for the EVO SDDC Manager. And what you can see is that we're specifying our first rack. When we're specifying this rack, in order to build that common set of services, we're going to build out a management cluster. And to do that, we need to specify some networking, including management, vMotion, vSAN, and VXLAN. But this management cluster is not an island. It needs to integrate with the rest of the data center. And for that, we actually specify data center connectivity as well, including external IP addresses, gateway, and DNS. We review our settings to see what we've put in is correct and connect. And what will happen here is we'll set the IP addresses for those common services infrastructure, including log insight and vRealize operations for logging, monitoring, and capacity management, the Platform Services Controller, so you have a single sign-on capability, NSX for software-defined networking, vCenter, which will be the vCenter to manage the other private cloud vCenters that you form over time, and finally, the EVO SDDC Manager, the single pane of glass to manage both physical and logical infrastructure in your new SDDC. So we hit confirm, and that's it. You go to lunch, and in a couple of hours, we're going to build out that management cluster, and we're going to configure both the top-of-rack switch and the spine switches that came with that EVO SDDC BOM to enable this rack to communicate across racks and into your existing data center. And that's it for setup. But Raj, once we've set this common services platform, what can we do with it?
Okay, thank you, Anil. So going back to the talk, once you have this SDDC-based private cloud running up and running, what you get out of this is really what we call a virtual rack. The notion of virtual rack is that no matter whether you have 1/3 rack or multiple racks, we pool all of that capacity across compute, storage, and networking into what we call a virtual rack. That capacity is available to a cloud admin or IT administrator to start carving it up into different workload domains so that you can decide that you want to carve up the capacity targeted at, say, infrastructure as a service, maybe VDI or big data, and you can associate different policies with respect to amount of capacity you need, availability characteristics, and performance characteristics. And all of that you can do with just a few clicks. In addition, we have integrated network virtualization product we have called NSX that comes with a security in terms of microsegmentation. So now what you can do is, within a workload domain, you can deploy per VM policies, firewall policies, access control policies, but you also can build policies between the workload domains to protect one workload domain from another. So as a result of all of this, you get workload domains. That's an abstraction in terms of you manage capacity. Underneath, what happens is purely automated through the EVO SDDC Manager. And at this point, I would like to request Anil to show you another demo of how to use these workload domains. Anil?
So Raj, before I show you this EVO SDDC Manager and we get into the demo, I'm sure people in the audience are wondering, why do we need another manager of managers? I mean, aren't managers just overhead?
Wow. That's for the next review. Go ahead.
Oops. Okay, so here's the EVO SDDC Manager. And the first thing I want to point out is that it's just beautifully simple and focused on exactly what you need to do, which is building private clouds. It contains a number of functions, such as roles and permissions. It's got monitoring for both logical and physical infrastructure. It allows for updates of that infrastructure, including the firmware, as well as allows for modification of the settings that we've automatically set for you. But today we're going to talk about building out a workload domain. And there's really two options available for now, and that includes virtual desktops as well as infrastructure as a service. And what we mean by that is we're going to build out a vCenter with a series of hosts. There's a few things that customers care about when they're building out that vCenter and those hosts. It includes, how do I make capacity decisions? How do I set performance parameters? And how do I set availability parameters? And that's exactly what we've optimized here in the UI. We'll name this workload domain, and I'll point out that what we have here is the full capacity across racks and across your data center. So it's a single pane of glass for your entire data center. And here we will specify CPU, memory, and storage for this IT initiative. Next, we have to set performance and availability characteristics. And we've simplified all of those SDDC parameters down to just 3: development, staging, and production. Choose production. And what that means is more than just enabling DRS for compute and memory. It means that we're setting storage policies as well, such as vSAN striping, and NIOC policy, and a number of other policies that we'll have to set both for virtualization layer and for the physical infrastructure. Next, customers will worry about availability. And we've got those best practices simplified as well, down to 3: low, medium, and high. When you set it to high here, it means more, again, than just setting vSphere HA. We have to set storage policy, networking policy as well, such as the number of replicas for vSAN. And we do that all behind the covers and set by VMware experts so that the next time that you do one of these workload domains, you know that you're getting the best practices embedded in the workload domain. We hit Next and review our networking configuration. And just like before, we need to be able to set the networking and integrate this workload domain with our external data center, our existing data center. We click Next to review, and that's it. After we hit Finish, we'll actually build out this workload domain. We'll build out a vCenter and populate it with hosts with all the policy settings that we've just formed. So now you have this private cloud built, but how do you keep it up to date and secure? I mean, if you don't keep it up to date and secure, it is fundamentally insecure. I mean, it's almost as insecure as I feel about my job right now, Raj.
You better feel insecure at this point, but I want to get back to the talk. So going back to the talk, I think what you just say is the workload domain concept and how do you go about using those. One of the things that Anil pointed out is the biggest problem, as I said, lifecycle management. So one thing we have done as part of this product is that we want to automate both hardware and software lifecycle management of the entire stack, starting from firmware, BIOS, drivers, all of the VMware stack, and so on, in terms of both applying updates as well as patching. And we have to do that in a non-disruptive way, provided there's spare capacity available. But that part also is automated in the sense that the cloud admin or IT admin can specify when and where they want to apply the patches and upgrades, and we'll take care of the automation of that. And I'll talk about that in more details in a minute. So just to recap, I started with this notion of hybrid app that can run everywhere, that requires both public cloud and private cloud. Private clouds do not have either the agility or the availability of the public clouds today. In order to provide that kind of characteristics of the private cloud and make it easy for the enterprises to be able to create private clouds and deploy them, we have an architecture called a software-defined data center. I talked about the challenges that are associated with the software-defined data center in terms of instantiating it, deploying, managing, and operating it. The EVO SDDC product that we want to deliver in partnership our OEM or ODM partners tries to create an integrated suite which has very easy bring up because everything is pre-integrated, pre-installed. You can bring up the entire private cloud in less than 2 hours. But more importantly, then you can start dealing with that private cloud at the abstraction of virtual rack so that you can carve out capacity, allocate it, manage it, and so on, and including do the automated lifecycle management. The next, I would like to go into more details of what we do as part of this product, what's inside EVO SDDC. So as I said earlier, that EVO SDDC is a product initiated and, by VMware. It has key components that are listed here. It starts at vSphere, Enterprise Plus class, vSAN, NSX, a login site, vRealize operations, and optionally either vRealize automation for infrastructure as a service, or Horizon View infrastructure for VDI, or combination of the two, because we do allow concurrently both of those workloads to run in the same environment using virtual rack notion. All of this is integrated together using EVO SDDC Manager. We have a notion of hardware management services. This is the hardware abstraction layer we built so that we can support servers, switches, PDUs, and auxiliary devices from multiple vendors. So you take all of this, then we work with the partners who provide management switches, top-of-the-rack switches, spine switches, servers, and other auxiliary devices. All of that is integrated by our partners to deliver an integrated solution powered by VMware EVO SDDC. And that comes with all of these components that are listed here, including the EVO SDDC Manager that centralizes both physical and logical infrastructure management, lifecycle management, and so on. So just to recap about how you go about getting such an environment, or where do you get the product from? So you would normally have a sizing and BOM configurator tool that allows you to specify your requirements, size of your private cloud. And that bill of materials configurator will spit out a BOM or bill of materials that goes to our hardware partners. We provide them a software stack that goes with it, which is prescribed in terms of each version of the firmware, BIOS, drivers, and our VMware components. We provide an imaging appliance that is used by the partner in the factory for assembling the rack, pre-imaging, pre-configuring, and pre-installing the whole stack, including the IP addresses. And it is pre-integrated, tested, and partner ships such a rack to the customer. It comes to the customer on day 0. They connect the network and power. They bring it up. The first thing is hardware management service that comes up, verifies the inventory is ready. Then our EVO SDDC manager comes up and does the automation of creating necessary clusters, management clusters, and so on. And at the end of the process, you have the private cloud ready to go. So in terms of the EVO SDDC manager as a component, it is responsible to do power on inventory validation when the whole private cloud comes up or the rack comes up. That takes care of detecting failed components, DOA, servers, and so on, so that at the end of that process, you have a capacity that is validated, ready to be used. Then we take the input from the customers that Anil specified. At the end of that, we create the management cluster. That's where we integrate all of our management components, including the EVO SDDC manager, the whole SDDC stack that comes from VMware. We create the vSAN data stores. We realize products are configured. We also configure the management networks and other physical networks and logical networks, and our cluster configurations are done. All of that step is automated by the EVO SDDC manager, and at the end of which you have workload domains to be deployed as a result of this. Now, when it comes to workload domains, there are multiple steps involved with respect to how you go about building it and what EVO SDDC manager ends up doing. So this particular slide captures what the requirements that are specified by the user, either using APIs or your user interface. And they include, as I said earlier, capacity, availability, and performance requirements, and they could be characterized by production, dev, test, non-production kind of workloads. That input is taken by the EVO SDDC manager. It translates those capacity, performance, availability requirements into CPU, memory, storage, and networking capacity necessary, storage policies, selecting devices from multiple racks to go across the fault domains so you can provide availability necessary, and also deciding how the storage striping, the vSAN striping should be done, vSAN fault tolerant policies should be applied, and so on. Once that is done, the EVO SDDC manager automates the ASX cluster creation, configuring the availability or HA features, creating the vCenter, connecting the clusters to the vCenter, do all the network, physical network configuration, logical network configuration, bringing up the entire NSX infrastructure with respect to NSX manager cluster, NSX controllers, and so on, and then setting up the vSAN disk groups, striping, and so on. And finally, we also configure all of the vRealize components, including vRealize operations and vRealize login side, so you can start monitoring both physical and logical infrastructure, get alerts, events, and so on. And also, they can be displayed in the EVO SDDC Manager UI for administrators to look at the conditions that are operating inside EVO SDDC. And finally, you have the workload domain, and that's how you start creating the VMs, deploying them, and start migrating workloads to this particular private cloud. In terms of the lifecycle management, as I said, this whole stack starts from partner software. They provide firmware, BIOS, switch operating system, and so on. Plus, we have vSphere, vSAN, NSX, and vRealize suite, and our software in terms of hardware management service and EVO SDDC manager. So part of the lifecycle management is to make sure all of this is created, pre-tested for interoperability. So it's integrated in a way that we do not want people to simply pick any patch or upgrade available from a partner. For example, a partner may put out a new firmware upgrade, and that upgrade is necessary for this particular stack. But we don't allow, in this particular model, for the customers to simply download a patch or upgrade and apply it to the stack. Instead, this lifecycle management process is based on the notion of predefined software bundle. That's defined by us. We know the configuration that our customers are running, so we can pick particular versions, test them, integrate them for interoperability. So the bundle consists of very specific versions of component software, which is pre-validated. And we always publish these bundles as part of the EVO SDDC manager. Once you do that, how you go about applying those upgrade bundles or patches is also defined by EVO SDDC product. So for example, for the features, updates, new features coming out, or you're going from 6.0 vSphere to 6.1, we have what we call upgrade bundles. And those will be available every quarter. It's sort of a train model. The train arrives every quarter, you decide whether to get on it or not. And if you decide to get on it, then you get to choose which bundles you want to apply and where do you want to apply. For example, you may select to apply to certain workload domain. You may also select when to apply them. Once you specify that, our software automates the process of actually applying the upgrades and updates and also backing off if there's some, or doing the rollbacks if something fails. In addition, even though we have such a quarterly model of releasing new updates, it's possible that sometimes the partner might, or even VMware might put out a critical update because there's some critical bug found and you need to apply an asynchronous update. Or you may have a security event like a shell shock or heartbleed. In response to that, you have to put out a security update. Those updates will be made available through an asynchronous bundle, which are pre-tested by us. So as soon as a patch or update is available, it's from VMware. We'll be working with our internal product teams to make sure that it's pre-tested in our environment, so we can put out a bundle that works for a particular configuration that a customer is running for. So you have a combination of quarterly process, which is very regular, expected, where you get to choose when to apply the bundles, where to apply them. But you also have asynchronous updates, which are pre-qualified, pre-tested, and they will be available on as-needed basis. So the next question comes is that when you put up these racks, do I have any flexibility with respect to compute, memory, storage, networking, and so on? So here's an example of a single rack, assuming about 12.5 kilowatts of power for a single rack. The single configuration may look like 24 nodes, 24 servers. That go into the rack. You don't have to buy the entire rack. You can start with as less as 8 nodes and add 1 node at a time. But you're allowed to go up to the power limit. Some of our customers have only 5 kilowatt power in a rack, not 12 kilowatt. In that case, they would start with a much smaller number of nodes. But you get to choose the number of CPU cores, amount of memory per node, and also the amount of directly attached storage in terms of both number of hard drives and SSDs that you need for vSAN. In addition to the 24 nodes in the rack, we have 2 top-of-the-rack switches, 10 gig links, so that each server can have 2 10 gig links going up to the top-of-the-rack switch. This top-of-the-rack switch also have corporate connectivity from the top-of-the-rack switches to the corporate network based on 10 gig links or 40 gig links. In addition, each rack has a management switch that's responsible for out-of-band connectivity to all of the BMCs on servers for out-of-band management using a non-routable IP network. And finally, for inter-rack connectivity, when you scale to multiple racks, you have 2 spine switches, which are 40 gig switches, provide redundant capacity as well as a failover if one of the spine fails, so you have some level of availability there. In terms of network deployment model, let's take an example of a single rack. If you have a EVO SDDC based on a single rack, you typically will have multiple servers in a rack. Each of them has 2 10 gig NICs going to 2 separate top-of-the-rack switches for redundancy and availability. Plus, you have a management switch that has out-of-band connectivity to each server for out-of-band management. And then to connect to the existing data LAN from the top of the rack switches, you have a 40 gig or 10 gig links going to the data center LAN. All of the traffic that runs within the rack stays within this EVO SDDC complex. In that sense, a self-contained private cloud. And what you have is a corporate connectivity for all the northbound traffic going to the corporate network or to the internet. The connectivity to the corporate network through the uplinks is based on either layer 2 connectivity or layer 3, depending on what the corporate network choice is. So we support both of those. And you get to use the same network management tools that you're familiar with in your environment. So this is not an island. We can easily integrate that in an existing data center network. Now, once you go to the multiple racks, the scaling is similar. You have 1 or more racks. All of those racks come with their own management switch, their own top-of-the-rack switches, their own servers, and so on. Now, this top-of-the-rack switches attached to the spine switches so that you can get inter-rack connectivity. That's through, again, redundant 40 gig links. The spine switches also act together in concert. They are connected together. So what you get out of this is the single instance private cloud. All of the east-west traffic within this private cloud stays within this environment. And only point of attachment is from the first rack, where the top-of-the-rack switches connect to the existing data center LAN, just like previously. So what you're getting out of this is a very high degree of bandwidth throughput available for your inter-VM communication, vSAN, vMotion, and so on. and external data traffic still goes to a data center LAN. Finally, I think one of the things is what's the software architecture for this entire SDDC suite, EVO SDDC product. So on the left-hand side, you'll see at the bottom, you have the partner hardware. Then you have the virtualization stack that you're familiar with respect to NSX, vSAN, and vSphere. Then we have the operations and management components integrated together. We have EV automation available for infrastructure as a service. We also automate integration and installation configuration of Horizon View for the VDI workloads. And all of that done on the right-hand side by the new software components, hardware management services, which is an abstraction layer. Then EVO SDDC Manager I talked about earlier, that does provide you a very nice API for simplicity through which you can manage the entire infrastructure, physical or logical workloads and so on. On top, it does have REST APIs so that you have northbound APIs that can be used for integration with existing management tools. These are the APIs we also provide to our partners so that they can add differentiation on top. Such as they have their own cloud services manager, they may have integration with hybrid clouds, they might do IPAM-like integration, data protection, data recovery, disaster recovery, those kind of services integrated using these northbound APIs for differentiation by our customers, partner side. The hardware management service, as I said, is a hardware abstraction layer. So if you look at the picture on the right at the bottom, what HMS exposes to the EVO SDDC Manager is this abstract objects called servers, switches, PDUs, auxiliary devices. Those are completely independent of a particular hardware vendor. At the bottom of those abstract objects, you have hardware management API, which is a pluggable framework in which our partners can write plugins for their hardware, vendor-specific hardware features that they can plug into that particular API. So that way what happens is that we can support multiple types of hardware, including hardware based on OCP, coming from white box vendors, OEMs, same thing for switches and switch operating systems. On the top, HMS will expose the northbound API and inventory in a more abstract way to the EVO SDDC Manager. It's responsible for hardware discovery, auto-discovery. When you add a server, add a switch, or a new rack, HMS can discover it, auto-discover it. It can do physical inventory of the hardware. It does hardware monitoring, including capturing alerts and events from the hardware, and also does low-level upgrades for the firmware BIOS and so on. So all of these things are available to the hardware management services. As we have discussed before, we plan to put out the code for the hardware management services in the open source soon so that we can build an ecosystem around it that is hardware agnostic and can continue to support and expand EVO SDDC portfolio. Just to summarize, in terms of EVO SDDC Manager, which is a central component of this particular infrastructure, we have the focus is on creating as much automation and simplification to create a significant reduction in infrastructure bring-up time. Because we pre-integrate, pre-install, pre-image, the customers do not have to go through the process of procuring, putting things together, configuring, and so on. So in less than 2 hours, you can get the automated bring-up of the private cloud to start using the infrastructure and creating workload domains and putting your VMs on them. It also provides a centralized management and integrated view of both physical infrastructure and logical infrastructure. You do not have to invest in multiple management tools separately to manage storage, networking, or servers, as well as VMware infrastructure. It's all integrated together in one place. It also does, since we are focused on doing interoperability testing and making sure upgrades and patches happen in a non-disruptive way, we automate the process of lifecycle management. So both hardware and software lifecycle management, including how you deal with field replacement units and all, is automated through the EVO SDDC Manager. And finally, I think in terms of once you are given this kind of a virtual rack notion and dealing with virtual capacity, you can focus on performance optimization, capacity management, and real-time log analytics using rest of the tools available from VMware through vRealize Operations, vRealize Log Insight, and so on. So overall, I think the idea is to be able to simplify creation of the private cloud in a way that we believe that it's the easiest and most efficient way to bring private clouds to the large enterprises. So you can realize the vision of hybrid clouds where you bring both agility and availability of public clouds to the enterprises on-prem clouds, and you can start running applications in a hybrid manner. As I said earlier, the product is based on working with our partners who will deliver the final solution, pre-integrated and tested, pre-qualified hardware and BOM. So this is a very important point. We do not have very wide funnel, but it's not a hardware compatibility list in that sense, because we'll be pre-qualifying particular versions of hardware and software. We expect to see our partners. Some of them we have already announced. We have our federation partner, VCE, which will be providing the federation-based solution. We have Dell and Quanta Cloud Technology. Those are the two other partners. They will bring to market EVO SDDC-based integrated solutions. And you can expect limited availability to the customers soon. With that, I want to point out some of the things. There are other sessions today happening that will be very useful to follow up. One of the sessions is by Jason Lockhead, which will be a deeper dive to go into more details of the EVO SDDC technical architecture. We have a customer panel where some of the customers who have been trying out the EVO SDDC-based solution in early field trials will talk about their experience. And finally, we have a session, again, a technical deeper dive on NSX integration that we do in this particular product. With that, thank you. And any questions? Please come to the mic if you have questions, by the way.
Question. How about the support? I mean, since we are partnering with the hardware vendors and getting the software pre-deployed, how we are going to get the support done? Is it one Windows support, or the hardware is going to be separate than the
support? So it's a one single support model in the sense that our partners will offer a single place you can call for support. And in the background, we will do triage and fan out the support requirements to partners or VMware. But you have a single person to go to, single support call to make to our partners to get the end-to-end support.
Right. Thank you.
Yeah.
So you mentioned predefined hardware. Could you actually mix and match different pieces of hardware like the storage network and compute? Or is it always bundled and one pre-configured?
So I think in terms of how the servers are pre-integrated in the sense that they're based on directly attached storage. So of course, when we define a BOM with our partner, they have a server model, they have a disk supplier for HDD and hard drive. That's models are predefined because for pre-testing purposes. Same thing about the switches. We have a particular switch model that we have qualified, pre-tested, that's included in the BOM. Now within a rack, we want to keep it homogeneous, but between the racks, you can have different vendors. So you can have a rack from one vendor versus another rack from another vendor. That mix and match is okay.
So you are actually simplifying but taking away the flexibility.
That's a very good point. I think you have to balance the amount of flexibility you need versus simplicity you need, right? Yeah, go ahead.
So what's the planned migration or upgrade path for customers that are already heavily invested in vBlock, vMax, vNX?
So I think if you already had invested, you have a running vBlock thing, and if you are expanding that capacity, we expect, for example, VCE is going to has announced a product called VX Rack. That's the way to start adding new capacity, and then VCE would then integrate into an existing vBlock infrastructure.
All right, thanks.
So my question is, once you have the rack installed, and I believe the terminology was when you deploy the world like you did your production, and so in that instance, and it will deploy a VC center, and you give it computing resources, SAN, and memory. Each time you deploy a world, will you have multiple VCs within that rack?
Yeah, that's a very good question. So I think whether you have one or more vCenter depends on how you organize your workload domains. Within a workload domains, you may have single vCenter that takes care of that workload domain, another vCenter for another workload domain.
Okay.
That's one option. That's the easiest option. Of course, if you want to have single vCenter manage multiple workload domains, we'll have to allow that too.
Okay.
But we do not want to create a forest of vCenters that you have to manage.
Right.
That's what we want to avoid.
Okay, thank you.
What, forest of vCenters doesn't excite you? My question is, you mentioned specifically that the equipment is pre-integrated and pre-tested. Does that mean you're shipping me a rack with equipment in place?
That's right.
And I'm literally rolling a forklift into my data center, dropping it, plugging in the PDU cables to the mains, and I'm online?
That's right. Yeah, that's the model.
Outstanding.
Yeah.
What's your lead time to ship something like that?
So that depends on our partners, because our partners are the ultimately responsible for doing the integration, test, and deliver the product. So I expect something like 4 to 6 weeks of lead time probably, but I can't give a definite answer. We'll have to get in touch with our partners. Yeah.
That's probably close enough. Thank you.
Yeah.
And what is the guaranteed lifetime of that hardware mix? Are you going to be able to update components? Are you going to make sure they all co-terminate in the end of life?
Yeah, that's a very good question. So I think the question is that when you go to the new generations of hardware, how do you upgrade to that? For example, I started with Ivy Bridge. I want to add Haswell. So within that BOM that we specify, we will allow for upgrades to happen from one generation to another for the same vendor, right? We have, as part of the field replacement unit policy, you would be able to upgrade to new hardware. But that again will be a pre-qualified BOM that you have to. You can't arbitrarily pick any server box and put it there. Yeah, but that's a very good question. Any other questions?
Hi, I have a few questions. Which type of vSAN you use?
Which type of what?
vSAN, virtual SAN, hybrid or all flash?
No, I didn't understand the question.
Which type of vSAN you use?
vSAN, what?
vSAN, virtual SAN, hybrid or all flash?
The
question is which vSAN version you're using.
Oh, I see. Got it. Okay. So I think the default is a combination of hard drives and SSDs, but all flash vSAN also can be used. That's depends on what BOM gets qualified, but we allow for both all flash or hybrid vSAN.
Second question. Do you have EVO configuration for heavy workload? For example, if I need connection between hypervisors more than 10 gigabit, for example, 40 gigabit or more.
So if you're asking within the rack, when I have each server with 10 gig NICs, instead of two 10 gig NICs, you want 40 gig NICs. The 40 gig NICs don't exist yet, by the way. They're not so, we'll probably go to 25 gig NICs first before we go. So you're talking about quad port NICs, like 4 port NICs, 4 10 gig NICs?
No, 2 40 gig NICs.
2 40 gig NICs from each server.
Yes.
Yeah, when they become common and our partners start supporting them, we'll incorporate that BOM. That's not a problem.
Third questions. What I do if I need rack number 10, 8, 11, 12, you see only 8 racks.
No, in the first version of the product, because the spine port density is 32 ports, we support 8 racks. If you're willing to buy 64 port spine, you can go to 16 racks. Architecturally, there is no limitation. Limitation comes to the cost, because the cost is prohibitive if you have to increase the port density on a spine.
Thank you.
Yeah. He knew answers to all my questions, by the way. Good questions. Thank you.
I'm going to ask a question on behalf of a customer who asked me the same question. Do you support external storage?
Yeah, so the external storage, the answer is 2 parts. If you have an external storage, you simply have IP-based external storage that you want to attach into EVO SDDC, you can do that. There's nothing preventing you from doing that. In the first release of the product, EVO SDDC Manager is not integrating the external storage in terms of automation that we provide with respect to configuration installation. We plan to do that in future, but the first release of the product, you'll have to do it yourself, which is possible today, even today, in any VMware environment.
Raj, do you have a list of partners who you have qualified to sell SDDC, and how can other partners join your program?
Sure. Today we are announcing 3 partners. Dell, Quanta Cloud Technology, and VCE, which is part of the EMC Federation. And we plan to add more partners next year. Any other questions? Thank you. Thanks.